Assalamu alaikum everyone. So let's continue our discussion on the topic of leveling. So now we'll see a couple of definitions. So like we discussed, leveling is defined as a process in which you find out elevation difference between 2 points. And the objectives of leveling can be two. One was related with control survey, in which you find out elevations of different points on a piece of land to gain vertical control of the area. And the second one would be to execute a project. So that would mean in the office you could come up with a project whose elevations are different, and then you go in the ground, you need to execute those elevations. So you need to execute construction over there, and you need to set out those points at different elevations. So one is about finding out the relative heights of different points before the project, and the second one would be, if you're executing the project, you need to go in the field and set out different points at height levels which are previously known, so you know them when you design the project. So these are two objectives of leveling, and the uses can be many. The first use is to prepare a contour map. So I won't go into detail of contour map over here because we have a whole topic of contour map coming up in a few lectures, after a few lectures, so we will talk about it over there. But leveling process is basically the input to contour maps. And the other uses are to execute a number of projects. They can range from any kind of a construction project. So whenever you have a civil engineering project, I think leveling does come into play. Now we'll see a couple of definitions. The first definition is level surface or level line. So this is a surface or line in which all the points are at the same height. So what that basically means is that, let's say you have a reference point, and this would be the level line or level surface. On this line, all the points are at the same height from the reference. That is called as level surface or level line. Now, since if you draw it on a bigger scale, so that means that the surface of the earth is not flat. So if it's not flat, that means if you want to have points at equal elevation, or you want to have a level line, so in actual, from the reference point, the level line would be a curve, since that is the natural trajectory of the surface of the earth. It's a curve. So this curve would have points at the same height from that reference line, because the shape of the earth also is in the same curvature. So this line is called as a level surface or a level line. Then comes horizontal surface or horizontal line. Now this is a plane, flat surface or straight line which passes through a point at right angle to the pull of gravity at that point. It is therefore a tangent to the curve of a level surface. So if this is my level surface, the tangent to this surface would be a horizontal line. And this is basically your line of sight or line of collimation. So when you perfectly level your instrument, the plane of your instrument is not a level surface, it's actually a horizontal surface or a horizontal line. And that is when your instrument becomes perfectly leveled. When you achieve this horizontal line, or when you achieve this tangency to the curved surface, which is the level surface. Then comes the datum surface. So, like we discussed before, that datum is basically any reference point from which you find out elevations. So let's say you're doing survey over here, and you select the lowest point as 0. So this 0 line would be your datum, and the elevations of all the points would be with reference to this line which is at 0. Even if your ground surface goes below, so these points would have a negative elevation. So the datum usually is the mean sea level, which is called as a 0 line, and from there you find out elevations of different points. So in essence, basically it is just a reference point or reference line. Then you have this term which is called as reduced level. Now, reduced level is vertical distance of a point above or below the datum surface. So when you use datum as a reference line, the elevations of different points are called as reduced levels. In essence, they are just elevations, the difference in height from the datum, but we use the term reduced level for them. Then we have this term which is called as benchmarks. So if you're working with mean sea level is a datum, and let's say you want to work with the same datum, or you want to work with the same reduced levels. So that means when you start your project, you need to have a benchmark. Let's say this point is my benchmark. Benchmark means a point whose reduced level is known, and the reduced level is difference in elevation from the datum. So your benchmark can have any reduced level. Let's say my benchmark has a reduced level of 106 meters. So that means this point over here is at a height of 106 meters from the datum. So any point whose reduced level is known can become your benchmark. So when I perform leveling and I find out the reduced level of this point, which would be greater than 106 because it is at a greater height, let's say it is 108.2. Now this point has now also become my benchmark since its reduced level is known. So whenever you find out elevation of a point above or below the datum, that point becomes your benchmark or your new reference point. Then comes backsight, foresight, and intersight. So I'll explain them combined because they are all interrelated. So let's say you are doing survey over here and you set up your instrument over here. When you set up your instrument, the first reading that you take is called as your backsight, and the last reading that you take is called as your foresight. Now, there could be a case that you set up your instrument and you just take two readings, first and last, just two. So in that case, you would just have a backsight and a foresight. But whatever readings you take between them, infinite number of readings, so all of them would be called as intersights. So the first reading is called as the backsight, second, third, fourth, whatever number is called as intersight, and the last reading is called as foresight. And all of these readings are taken with the same location or same setting of the instrument. If I change the setting of my instrument, then you would have a new backsight, new intersights, and new foresights. Usually, the backsight is taken at a point whose reduced level is known. So the backsight is basically taken on a benchmark. And when you take the intersights and the foresight at the end, all of these points become your benchmarks. And when you change the location of your instrument, then again the first backsight or the first reading that you would take, that would be against a point whose reduced level is known. So that would be on a benchmark. Then we have turning point or change point. So let me draw a random surveying plan. So let's say I want to survey this land, and this point A is my benchmark, and I have to find out elevations of point B, C, D, and E. And the distance between these points is huge. So let's say I first set up my instrument over here and I take my first reading at my benchmark point A, that would be my backsight. Then I take a reading at the point B, that would be my intersight. Then I take a reading at the point C, that could be my intersight, but then I see that it's difficult for me to view the staff or take the reading at the point D because it might be too far away or there is some obstruction that is blocking my view. So in that case, the reading at the point C would become my foresight and the one at B was my intersight. Now I change the location of my instrument. I bring my instrument over here. Now, when I bring my instrument over here, the first reading that I have to take is on a point whose reduced level is known, on a benchmark. So let's say I take it at the point C. Now, this reading at the point C will now become my backside. And then the reading at the point D will be intersight. And the reading at the last point E will be foresight. Now, this point C is called as the change point because I am taking two readings at this point, one foresight and one backside. The foresight, which is the last reading of my first setup of the instrument, and then the backside, which is my first reading of the new setup of my instrument, since point C had become my benchmark. So that point C is called as a turning point or a change point. So remember, at a change point, you always have two readings. And then comes the term height of the instrument. So what we have discussed up till now was that wherever you set up your instrument and you have a constant line of sight and you place the leveling staff at 2 points, the difference in reading between the two leveling staffs give you the elevation difference between the 2 points. So that is one way to perform leveling. The other way to perform leveling is that you set up your instrument and you usually take your first reading at the benchmark. And remember, benchmark is the one whose reduced level is known. So let's say I have a benchmark whose reduced level is 100 meters. That means it is 100 meters above the datum. Now when I draw my imaginary line of sight or line of collimation and I take my first reading at the benchmark, whatever reading I get over here, that would be the reduced level of my line of sight or line of collimation. So this is an imaginary plane, and I have found out reduced level or elevation of an imaginary plane, and this reduced level is called as height of the instrument. So what I did was I took the reading at the point of the benchmark, and the reduced level at the benchmark was 100. And since my line of sight is at a greater height, so I would get some value on my leveling staff. And let's say I get a value of 3 meters on the leveling staff. So my height of instrument would become 103 meters. 100 for the benchmark plus 3. That means the line of sight or imaginary line is 3 meters above this benchmark. Had my line of sight been at the same level as the benchmark over here, then the leveling staff would give you a value of 0 and my height of instrument would be 100, the same as the benchmark. But if it is above or lower than the benchmark, then it would have a different reading, and this reduced level of my imaginary line of sight is called as the height of the instrument. Then I have this thing which is called as chainage. So chainage is basically horizontal distance from a fixed reference location. So chainage is usually given in the terms of RD, which means running distance. 160 plus 25, these are reference marks. So chainage basically allows you to locate different points in your project along a straight line, or this is a linear distance. So let's say you are building a huge bridge, and on that bridge you have a number of pillars, and this first pillar is my reference point. I call this as 0. So the chainage of the other pillars would be the distance from that reference line. So let's say this is 2, this is 4, this is 6, this could be anything. So they basically tell you about location of different points. And usually you fix a number before that. So I can say this is not 0, this is 20. So this would become 20 plus 2. This would become 20 plus 4. This would become 20 plus 6. So how much farther it is from a reference point. And that reference point 20 tells you another story. How far that reference point is from some other reference point. So this basically comes into play usually in the case of railway tracks or canals. You must have seen this figure written RD 100 plus something or something like something similar. So as an example, you can say that if I have a overhead bridge that has hundreds of pillars and I want renovation work at one of those pillars. So this RD would tell my people exactly which pillar I am talking about, right? So this is change. This is just horizontal linear distance from a reference point. Then we have line of collimation. So line of collimation is an imaginary line passing through the intersection of crosshairs and the optical center of object glass and its continuation. It is known as line of sight. So ignore these terms as of now. Optical center of object glass and intersection of crosshairs. So we'll discuss this when we discuss the parts of the instrument. But this line of sight is basically what we have been talking about all along. So when you set up your instrument, what you see from it, that imaginary line, which is your line of sight, is called as line of collimation. So it is an imaginary line that remains horizontal. Then the next definition is geoid. So geoid is basically a reference datum. So geoid is the shape of the surface of the oceans under the influence of Earth's gravity and rotation alone, in the absence of other influences such as winds and tides. So we discussed a lot about datum. Datum is basically a reference point, right? And usually we use mean sea level, which is the next definition. But mean sea level is influenced by winds and tides, while geoid is an imaginary surface level which is without their influence and it is used in basically astronomical observations. What we use in survey is the mean sea level, which is the average height for the surface of seas for all stages of tide over a long period of time, 10 to 20 years. So, since the mean surface level of seas and oceans keep on changing due to tides and waves, so the average height over a long period is called as mean sea level. And then vertical control. So we've talked a lot about this. It is a series of benchmarks or other points of known elevation established throughout an area. So different points, they can be in a sequence or they can be random, and finding out their elevation, so that gives you vertical control over an area. Now we talked about benchmark. So benchmark was a point whose reduced level is known. Now we can have different types of benchmarks. We can have a permanent benchmark, temporary, or arbitrary. So a permanent benchmark is the one that is set up by government organizations for general use, and usually they locate it using permanent points, permanent concrete pillars or steel or other material fixed in the ground. So that is done by the government organizations, Survey of Pakistan in our case. So basically, what they do is they set up these benchmarks. So let's say they would set up a benchmark at a particular location in Lahore, that this point in Lahore has a reduced level of this much. So that's the benchmark. So if someone wants to execute a project in Lahore, they can use that benchmark and then they can shift the level to their location and find out reduced levels of their particular locations using the permanent benchmark. Then we have a temporary benchmark. So this is set up temporarily for any project at the end of day's work. So let's say you're working on a project where you have to find out reduced levels of a number of points, and you need to continue your work over different days. So in that case, at the end of the day, you can mark any point on the ground. It can be a rock, it can be a tree, and you can locate a line. So let's say this is a tree, and I can place a red mark on that tree, and I can say that the reduced level of this line, this red line on the tree is this much. So this line on the tree becomes my temporary benchmark, so that when I come back the next day, I can use this as my reference and continue my work. Then we have arbitrary benchmark, which is assumed reduced level to carry out leveling for localized project. So the permanent and temporary benchmarks are for when you want to use the real reduced level. The when the datum is the mean sea level, so the elevation difference from the datum. But usually in localized projects, so let's say you're constructing a building, you shouldn't be concerned with how much the height is from the sea level. So you just are concerned that whatever work you do over there, the levels are proper with reference to some local point, right? So in that case, you can introduce your own datum, your own benchmark, and that arbitrary or assumed point will be called as arbitrary benchmark, whose reduced level can be of any value, 0, 100, any value. Because whatever you do after that, what matters is the difference in elevation of points from that reference. And all the points would have difference from that the same reference. So it doesn't matter what value you give to that benchmark that you have assumed.